Let's continue solving this question. I took the given and the equation. So let's start with part A. Calculate the concentration of sodium carbonate solution in moles of sodium carbonate per cubic decimeter. So in this question, we have to find the concentration of sodium carbonate in moles per decimeter cubed. Let's read the given together. The first part is useless for now. We'll start from the second part, from here. A 25 centimeter cubed sample of this solution was neutralized by 40 centimeter cubed of 0.125 moles per decimeter cubed hydrochloric acid. So hydrochloric acid has a volume of 40 centimeter cubed and a concentration of 0.125 moles per decimeter cubed. So I wrote down the given for hydrochloric acid. From the given, we have to calculate the number of moles of hydrochloric acid, which is volume times concentration. The volume, as you can see, is in centimeter cubed. However, the concentration is in decimeter cubed. So I will convert the volume from centimeter cubed to decimeter cubed by dividing by 1,000. So the number of moles will be 0.00500 moles. This is the number of moles of hydrochloric acid. So I'm done with the first step. The second step is to look at the equation and see if I can make an interpretation. So previously we found the number of moles of hydrochloric acid, but let's find the number of moles of sodium carbonate. Let's do an interpretation for this equation. 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid. Notice we have 1 mole here and 2 moles here. So the number of moles of hydrochloric acid is double the number of moles of sodium carbonate. So if I want to calculate the number of moles of sodium carbonate, I have to find the number of moles of hydrochloric acid and divide it by 2. So the number of moles of sodium carbonate equals the number of moles of hydrochloric acid divided by 2, since we have 2 moles of hydrochloric acid in front of 1 mole of sodium carbonate. So I divide by 2 to get the number of moles of sodium carbonate. The answer will be 0.00250 moles. So this is the number of moles of sodium carbonate in 25 centimeter cubed sample of this solution. Meaning we have to calculate the number of moles of sodium carbonate found in 25 centimeter cubed of the solution. But when I want to find the concentration, I want it in decimeter cubed, not in centimeter cubed. So I will put that 25 centimeter cubed contains 0.00250 moles sodium carbonate. But I want in 1 decimeter cubed, meaning in 1,000 centimeter cubed. Why? Since 1,000 centimeter cubed equals to 1 decimeter cubed. So in 25 centimeter cubed, I do the cross multiplication rule to obtain the answer. 1,000 times 0.00250 over 25. So in 1,000 centimeter cubed, I have 0.1 moles. So I obtained the number of moles in 1,000 centimeter cubed or 1 decimeter cubed. So the concentration of sodium carbonate is 0.1 moles per decimeter cubed. So 0.1 moles are dissolved in 1 decimeter cubed or 1,000 centimeter cubed. So like that, We finished the first part of this problem, and we obtained the concentration of sodium carbonate in moles per decimeter cubed.